Section 5.4 problems. Problem 1. Use the figure to find the values of all 6 trig functions at t. Okay, so I've transferred the picture over here to a piece of paper, and so we can slide that off to the side. And we have point P on the circle, and we have the coordinates of point P. Okay, if you know that you're on the unit circle, then the definitions, as shown in the PowerPoint slide, are the sine of t, so t would be the amount of that measure right there. Think of that as a rotation. Sine of t is given by the y-coordinate of point P. Refer to the y-coordinate of point P, and you get 1/2. The cosine of t is given by the x-coordinate of point P. The x-coordinate of point P is square root of 3 divided by 2. Tangent of t is given by y divided by x. So a little bit of arithmetic here. We'll take 1/2 and we'll divide it by root 3 over 2. So that's 1/2 times 2 over root 3. 1/2 times 2 over root 3. So that brings us to 1 over root 3. So tangent t, rationalize root 3 over 3. So there's our tangent of t. Okay, once you have those three, then the reciprocal functions can be found. So if the sine is 1/2, then that tells you, let's see, move here, that the cosecant of t would be the reciprocal, so that's 2. If the cosine of t is root 3 over 2, then the secant of t is 2 over root 3, which we could rationalize there to be 2 root 3 over 3. And in the tangent down here, reciprocate that, cotangent t is the reciprocal. Now if we reciprocate this, we have to rationalize again. So instead, reciprocate this one right here, and you get just root 3. Okay. Now, let me make a point here that I promised during the PowerPoint slide. How is this similar to the right triangle definitions? Okay. So here we are at P, which is root 3 over 2, 1/2. Okay. Yes, this is the x-coordinate, this is the y-coordinate. So if we think about the right triangle definitions, okay, the x-coordinate is root 3 over 2, the y-coordinate is 1/2, and the radius is 1. So the sine is 1/2 divided by 1, y over r, which is still 1/2, the y-coordinate of point P. Cosine is x divided by r, which is still square root of 3 divided by 2. Okay. Now, notice that this is equivalent to a circle, let's do something specific. Let's say that this is 30 degrees here. So if it's at 30 degrees, our right triangle definitions from before would give this a value of 1, this a value of 2, and this a value of root 3. Now this is not on the unit circle since the radius here is not 1, right? We have to envision the circle here, not shown, so there's a circle here. Radius is 2. So to make the radius 2, what you do is you unitize the radius. Okay, what does that mean? Well, we make a proportional triangle is what we do. If this length is 2, we wish it to be 1, we'll divide this by 2. So 2 divided by 2 is 1. But if you divide that length in half, you have to also divide this length in half, that makes it 1/2. Divide this length in half, that's root 3 over 2. So these two here are proportional to one another. This one's on the unit circle, and this one's not on the unit circle. So the old definitions, cosine 30 is square root of 3 divided by 2, x over r, is consistent with unitizing that radius to be 1, and now cosine's just the x coordinate. So let me write that down here. Cosine of angle is x over r, which is root 3 over 2. Here, since the radius is 1, cosine of t is just your x coordinate, which is root 3 over 2. See, and they're consistent. So it's just two different ways to talk about it, and that might take care of some of the confusion. Okay, let's see what else we have. True or false, the range of the cosine function is all real numbers negative infinity to plus infinity. So there is a real number t in the domain of the cosine function for which cosine t equals 10. Well, no, if we look at the unit circle here as we had before, the cosine is the x coordinate on the unit circle, and that varies from 1 to 0 to negative 1 to 0. So, right, we say right there, cosine's bounded between plus and minus 1. So this statement here is not true. Cosine t can never be equal to 10. It's bounded between plus and minus 1. And the range of the cosine function is negative 1 to plus 1. The domain of the cosine function is all real numbers. So this is backward from the way it should be. Okay, let's see what else we got here. Use even and odd properties to find the value of cosine negative 60 degrees. Okay, since cosine is an even function, we know cosine of negative t is equal to cosine of t. So in this example, cosine of negative 60 degrees is the same thing as the cosine of positive 60 degrees. So this would be quadrant 4. This is quadrant 1. But because cosine tracks the x coordinate, they're going to have the same value. So the cosine of 60 degrees is 1/2. Okay. Use even and odd properties to find the exact value of tangent negative pi over 6. Okay, so we want tangent negative pi over 6. Tangent negative pi over 6. Okay, well the tangent of negative t is equal to the negative of tangent t, because it's an odd function. Okay, so that means that the tangent of minus pi over 6 will be minus the tangent of pi over 6. So we get the tangent of pi over 6 is 1 divided by square root of 3, negative 1 divided by square root of 3, or rationalize negative square root 3 over 3. Okay. See, the old way that we were doing this were to first make a picture of the given angle. Minus pi over 6 is an angle swept in this direction, negative pi over 6. We would then find the positive angle, positive coterminal angle alpha, and that was this one right here. That's our positive coterminal angle alpha. Once we did that, so let's see, alpha would be 2 pi minus pi over 6, so that's 11 pi over 6. So there's our coterminal angle. We would then find the reference angle for that, so let's draw alpha. Rotate this way in the positive direction. So there's 11 pi over 6. We would then find the reference angle. That's always here pinched between the terminal side of the angle and the x-axis. And we'd find the reference angle to be 2 pi minus 11 pi over 6. So getting that value, this is 12 pi over 6 minus 11 pi over 6 is 1 pi over 6. Then we would get the trigonometric value, here it's tangent, at that reference angle. And the tangent at pi over 6 is root 3 over 3. And then finally we would say, well, where are we? We are in quadrant 4 because we want the tangent of negative pi over 6. That's the given angle that we had. And that puts us in quadrant 4. And in quadrant 4, tangent is negative. Tangent t is less than 0. Therefore, our answer was negative square root 3 over 3. That's a lot of work. And it's all good stuff. But because the tangent is an odd function, we can use this periodic property and shortcut it immensely by simply getting the tangent of pi over 6 and taking the negative of that and obtaining the answer in that way. There's always more than one way to do things. It's good to know more than one way. Let's see what else we got here. Problem 5. Use periodic properties to find the exact value of cosine 405 degrees. Okay. Well, cosine 405 degrees, if it says periodic property, then we can subtract one period from this. So if we subtract 360, that leaves us with 45. So this is the same thing as saying the cosine of 45 plus degrees plus 360 degrees. So this is f of t plus p, because the period is a full rotation for the cosine. And f of t plus p is equal to f of t. So this is just the cosine of 45 degrees. The extra rotation doesn't contribute. And that's square root of 2 divided by 2. Okay. Problem 6. Use periodic properties to find the exact value of sine 7 pi over 3. Okay. Sine 7 pi over 3. So we can think of subtracting 2 pi from that if 7 pi over 3 represents a full period plus more. And by doing that, the sine of 7 pi over 3 is the same thing as pi over 3 plus 2 pi. Right? 7 pi over 3 minus 6 pi over 3, 2 pi, equals pi over 3. So pi over 3 angle plus a full rotation is the same thing as 7 pi over 3. Well, this again is f of t plus p. And f of t plus p is just f of t. So this is just the sine of pi over 3. Right? Pi over 3, or 60 degrees, we get its sine, and that'll be square root of 3 divided by 2. Okay. There was a much longer way that we did that last time, by drawing this angle in standard position, finding the reference angle, same as I did before with the tangent. Okay, what else we got? Use periodic properties to find the exact value. That's the last one. Well, I think we should do perhaps one more. So let's take a look at tangent 5 pi over 4. We didn't do periodic property with the tangent function, so that's what I think we should do. So this one here we did. So this is a new one. Tangent of 5 pi over 4. Okay, well the period here of tangent is pi. Okay, so you can imagine taking 5 pi over 4, 5 pi over 4, and subtracting pi. That'll leave you with pi over 4. So in other words, the tangent of 5 pi over 4 is the tangent of pi over 4 plus pi. This is f of t plus p, again, because the period of the tangent is only pi. So that result is the same as f of t. Here it's just the tangent of pi over 4